So in this video we are going to look at BFN-D connected to BFNC and its communication with RS485. So here we are having BFNC model. So if we look at the camera, we can see that we are having BFNC model, and we also have BFN-D over here. So both of these models are connected by an connector in between. Okay, so BFNC gives us option to have RS485 communication and transfer the amplifier's data through RS485 communication. So let us see how we can check the communication parameters and how we can see the data in DAQ Master. So if you look, the BFNC right now is showing weight. Okay, so to access the communication parameters, we can press mode button over here. So after pressing mode button for some time, we have entered the menu, and the current communication over here is USB. So with USB communication, it enables the communication through this port, this loader port. So we are communicating with this wire, which is giving us RS485 communication between wires A plus and B minus. So I will change over here from USB to RS485. Communication address is slave ID is 1, baud rate is 1152, parity is none, stop bit is 2. Okay, so these communication parameters we can access directly, and also we can change it from here. So now it is waiting for the communication. So let us look into DAQ Master and see how we can communicate these devices. So in DAQ Master we can select the BFNC device over here and select the serial communication. So the device gets added in my systems. Here we need to verify the COM port settings of COM7 in my case. So for COM7, which has been taken for my 485 to USB converter, baud rate setting we need to match 1152, parity none, and stop bit was 2. So we'll change the stop bit. Okay, bytes, bit per byte was 8. Yes, all settings are matched. Now we can connect the COM port and we can scan for our BFNC slave address having slave ID 1. Okay, so we are able to successfully communicate to it. So the device have been added. Now we can say read all parameters to check all the parameters of the device here. Parameters which are available are setting value, SV value. This you can also compare it from here. The green is the SV value, which is 600. Okay, standard 1 point, dark on, NPN off. So these settings all we can change and we can verify it over here. Okay, now let us see what data we can take from the IO list here. So we are having channel 1 output, PV value, high peak value, low peak value, counter value, and few error registers. Okay, so these values, let's add it to an graphic device grid view and let's try to monitor them. Okay, so if I try to match it with the online status. Okay, so 9999 is the PV value. If I try to adjust the sensor, we can see the PV value is changing and it is matching as per the display. Okay, we can see the output turned off, output turned on. Here one more thing is there additionally in BFN, which is the counter value. So it also counts how many times the output turns on. So the counter value right now is 60 times the counter has turned on. Okay, I'll again turn off the output and I'll again turn it on. Okay, so we can see it is 62. Again I'll turn it off, turn it on, 63. Okay, so the number of times output turns on and off, it will count the value. Yeah, there is no register over here through which we can change the through which we can reset this values from mod scan. If you want to reset the value, okay, here also you can see we'll find that value in CNT online parameter. If you want to reset it, you need to press momentarily the set button. Okay, so the reset has to be compulsorily done from the set button. We cannot do it from Modbus or any input. Okay, so that was regarding BFNC communication. If you want to have the complete Modbus addresses for BFNC, okay, you can disconnect over here in DAQ itself, right click on BFNC and say print Modbus table, in which you will get addresses of all the Modbus registers required. Okay, and it is easily accessible from this. You can take a printout and we can make use of this. Okay, thank you.